So in this video we're going to solve a linear system that's in 4 variables. It's going to have infinitely many solutions and require more than one parameter to parameterize it at the end. So here's the system. The variables are x sub 1, x sub 2, x sub 3, x sub 4. We start as usual by making an augmented matrix. So we read off the coefficients for equation 1. So we get 1, 2, negative 1, 3, and the constant term is 4. We're creating that augmented matrix. For the second equation, we have coefficients 2, 4, negative 2, 7, and the constant term is 10. And for equation 3, the coefficients are negative 1, negative 2, positive 1, negative 4, and negative 6. And again, the idea is once we get our system of equations into matrix form, we want to put that matrix into reduced row echelon form, which means we need a leading 1 in the first row, which we already have. So now we zero the other terms out that are in the same column with the leading 1. It looks like we need to multiply negative 2 times row 1 and add it to row 2, replacing row 2 with the result to get a 0 in this position. So we're doing no changes to row 1. Row 1 has the leading 1, and we're zeroing out the column underneath it. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. Plus 4 is 0. We have negative 2 times negative 1 is positive 2. Plus negative 2 is 0. And here we get negative 2 times 3 is negative 6. Negative 6 plus 7 is 1. And we get negative 2 times 4 is negative 8. Plus 10 is 2. And now we need to get a 0 in this position underneath this leading 1. So it looks like we just need to add row 1 to row 3. Go row 1 plus row 3, replacing row 3 with the result. So we get 1 plus negative 1 is 0. 2 plus negative 2 is 0. Negative 1 plus 1 is 0. 3 plus negative 4 is negative 1. And 4 plus negative 6 is negative 2. So we zeroed out our first column, everything except the leading 1. We go down to the second row. It has non-zero elements. We need the first non-zero element to be a leading 1, and it already is, which means now we move to getting everything above and below it equal to 0. So it looks like I would need to do negative 3 times 1 plus 3 to get a 0 in this position right here. So I'm going to do negative 3 times row 2 plus row 1, replacing row 1 with the result. So I'm going to get a matrix here. And there's some stuff that isn't going to change. The 1 and actually everything up through this point right here will stay the same because there's a bunch of zeros, and then I've got my leading 1 here with my zeros underneath it. So nothing's going to change here, here, here. What we're working on is this position right here. We've got our leading 1 and we're getting our zeros above and below it, and nothing that we do to accomplish that will make any changes any place else in the matrix. That's to the left of the column that we are working on. So I did negative 3 times row 2 plus row 1, so it's going to be negative 3 times 1 is negative 3. Negative 3 plus 3 is going to give me a 0 in this position. Sorry, row 2 isn't going to change because we're using it to manipulate the other 2 rows right now. And then we get negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. And then right here it looks like I just need to add row 2 to row 3 to get a 0 in this position. So I need to do row 2 plus row 3, replacing row 3 with the result. So we get 1 plus 1 plus negative 1 is 0. And 2 plus negative 2 is 0. So our bottom row is all zeros. And reduced row echelon form says, hey, every row that's all zeros has to be on the bottom. It is. So we're done. And we actually now have this matrix in reduced row echelon form, and we just need to interpret the result. We want to remember that these columns correspond to our x sub 1, x sub 2, x sub 3, and x sub 4 variables. And the last column here, everything to the right of that vertical bar, is our constant terms. So interpreting this says 1x sub 1 plus 2x sub 2s minus 1x sub 3 equals -2. So we write that down. From here, 1x sub 1 plus 2x sub 2's minus 1x sub 3 plus 0x sub 4's, so I don't need to write anything for the x sub 4's, is equal to a -2. And then this column simply says that 1x sub 4 equals 2. So x sub 4 is just a constant. For this one, you go to your lowest subscripted variable. You solve for it in terms of the other variables. So I'm going to get x sub 1 equals, so I'm going to subtract 2x sub 2 from both sides and add 1x sub 3 to both sides. And I already have a -2 right here. And then we parameterize these variables that are controlling the x sub 1. So we say let x sub 2 equal r and x sub 3 equal s. And r and s can be any real number you want. So r and s are elements of the real numbers. So if we kind of catalog what we have going on, this means that x sub 1 is equal to -2 times x sub 2, but we just let x sub 2 equal r. And then it's plus x sub 3, but we just let x sub 3 equal s. So that's our parameterization. I have two parameters. And then it was minus a 2. We know that x sub 2 is equal to r. We know x sub 3, we let it equal s. And x sub 4 is always a 2 from right here. So as an ordered 4 tuple, our solutions are ordered 4 tuples: x sub 1, x sub 2, x sub 3, x sub 4. And in the parameterized form, they look like x sub 1 is really -2r plus s minus 2. X sub 2 is really r, x sub 3 is represented by s, and x sub 4 is a 2. My s's and 2's are not so good. And there's the solution to this system of equations. Infinitely many solutions, because there are infinitely many combinations of r and s that you can select from the real numbers, and all of them are solutions.